Hello everyone and welcome back to another Study Monster OCR Computer Science video. In this lesson we're going to be focusing on the architecture of the CPU, a core topic of the OCR J277 Computer Science specification. Today we're going to be breaking down what the CPU actually does, the components inside it, and how the Fetch, Decode and Execute cycle powers everything your computer does. By the end of this video you'll understand how instructions move through a CPU, what each register does, and why the von Neumann architecture is at the heart of all modern computing. The CPU, or Central Processing Unit, is often described as the brain of the computer. Its main purpose is to process instructions and data by repeatedly performing the Fetch, Decode and Execute cycle. Every program, every app and every action carried out on a computer is broken down into tiny instructions that the CPU handles one at a time. Whether that be opening up your favourite video game, accessing your favourite website using Chrome, or creating a presentation using PowerPoint, your CPU will fetch the instructions from memory, decode those instructions and then execute them endlessly, billions of times per second. To understand how the CPU works, we first need to understand the von Neumann architecture. Von Neumann systems use a simple but powerful idea. Both instructions and data are stored together in the same memory. This means the CPU fetches instructions and the data they need from the same place, main memory. The architecture relies on registers such as a program counter, the MAR or memory address register, the MDR, the memory data register, and the accumulator. These registers allow the CPU to keep track of where it is, what it needs next, and what results it has produced. So, on to the components. The control unit is responsible for managing the flow of data around the CPU. It sends control signals to the ALU, the arithmetic logic unit, the registers and the memory, main memory. Think of it as a traffic controller, organising what happens, when it happens and in what order. Next up we have the arithmetic logic unit, the ALU. It's responsible for performing all mathematical and logical calculations, addition, subtraction, comparisons like greater than or equal to, and logical operations such as the and, or and not. The ALU handles it all. Whether your computer makes a decision or performs a calculation, the ALU is at work. Next we have cache memory. Cache is a small amount of extremely fast memory built directly into the CPU. It stores frequently accessed instructions and data, meaning the CPU doesn't need to wait for the much slower RAM as often. The larger and faster the cache, the better the CPU can perform. Finally, we have a series of special registers. The CPU contains several special purpose registers. These are tiny, lightning fast storage locations that hold critical data while instructions are being processed. So let's break these registers down. First up, we've got the program counter. This stores the memory address of the next instruction which is to be fetched from memory. After each instruction is fetched, the program counter is incremented so the CPU knows where it's going to next. Next we have the MAR or memory address register, which holds the address of the instruction or data that the CPU wants to access in memory. Whenever the CPU needs something from RAM, the memory address register points to the exact location. Next we have the MDR, the memory data register, which holds the actual data or instruction that has been fetched from memory, or that is about to be written back into memory. If the memory address register shows where, then the MDR shows what. Finally, we have the accumulator, which stores the results of calculations carried out by the arithmetic logic unit, the ALU. Instead of constantly sending results back to RAM, the CPU holds them inside of the accumulator for quick access. So now that we've seen the components and the registers, let's walk step by step through the cycle that powers all computer processing, the fetch, decode and execute cycle. First up, we fetch the next instruction. So the program counter sends the address of this instruction to the memory address register. The CPU then retrieves the instruction from main memory from RAM and loads it into the memory data register. The program counter is then incremented to point to the next instruction. Moving on to the decode. Next, we're going to look at how the control unit decodes the instructions. So basically, it breaks it down into parts. Typically an opcode, which is the action to be performed, along with the operand data, which might be an address or a value. Now, you don't specifically need to know these terms for your exam, but the opcode is part of the instruction that tells the CPU what operation it needs to perform. Think of it as like a verb in a sentence. For example, add, so add two numbers together, or load data from memory. Whereas the operand contains the data or the memory location that the instruction will act on. Think of it as like a noun in a sentence. So for example, a number 5 or a memory address like 200, a register name for example. So data fetched into the memory data register might contain an opcode, add, and an operand, data 5. The C control unit then prepares the CPU's internal components for the action that the instruction requires. Next and finally, we will move on to the execute stage. Finally, the CPU executes the instructions. This could involve the ALU, the Arithmetic Logic Unit, performing a calculation, data being moved between registers, or a jump instruction modifying the program counter. Once complete, the cycle starts again. Fetch, decode, execute, billions of times per second. The fetch, decode, execute cycle is the heartbeat of every computer system. Without it, instructions can't be processed, data couldn't be manipulated, and nothing from simple calculations to complex games would be possible. So, what does the exam look for specifically? Well, you need to be able to describe each fetch, decode, execute stage clearly. You need to know the role of registers like the program counter, the memory address register, the memory data register, and the accumulator. You need to know what the control unit, the arithmetic logic unit, and cache do, and understand why the cycle is essential. And you need to be able to use the correct terminology. So remember, the CPU's purpose is to execute instructions and process data through the fetch, decode, execute cycle. The key components are the control unit, the arithmetic logic unit, the registers, and cache. Those specific registers are the memory data register, the memory address register, the accumulator, and the program counter. And the fetch, decode, execute cycle, in the fetch stage, we get the instructions from memory, or we fetch them from main memory. To decode it, we have to understand it, so we break it down. To execute it, we carry it out, and we repeat that forever, faster than you can blink. And that's it. So thank you for watching this breakdown of the CPU architecture and the fetch, decode, execute cycle. Understanding these key concepts will help you in your computer science course, especially in systems architecture questions. A separate video is going to be released later looking at common exam questions targeted at this area of the specification. If you found this helpful, make sure you check out the next video in the series, and don't forget to like, share and subscribe. And I'll see you in the next one. Bye for now.